Hey kids, here we are with our next video lesson. Okay, so you should have this note sheet out that says 1.1, solving simple equations. Very easy. I definitely have full confidence that you guys have done something like this before. It's almost so easy, it's almost hard to explain sometimes because I know you guys know how to do this. Okay, so we're just gonna jump in and see where it takes us, okay? So our learning goals, we are gonna use addition, subtraction, and multiplication, and division, I suppose, to solve simple equations. And then we are gonna use these simple equations to model real life problems, because really that's the point of math, right? Like to help us in real life, not just to do random problems on pencil and paper. So let's get started. We have some vocab that we're gonna fill out here. Again, I think you guys know these words, but it's just a good refresh for the beginning of the year. So an equation is just a statement that two expressions are equal. That I don't want a pencil though. I want a pen so you can read this, that two expressions are equal. If you want to jot down an example, something like 4x equals 8. That's an equation. It has an equal sign, and they're telling us that both of these expressions are the same. Even though they look different, that's kind of the fun thing in math. They're the same, but they look different. The solution is the answer when we solve an equation, is the answer. So whatever our answer is, we can call that sometimes the solution. This one might be a new word or a new set of words for you, but equivalent equations. Equivalent means they're the same, they're equal. So equations that might look different but have the same solution. So again, in math, we can manipulate a lot of things so they look different. But as long as they're equivalent, we can still use them. And then our last vocab word, I know you've used these before, you just might not have known that this is what they're called, but inverse operations are two operations that undo each other. So let's write that down and then we can talk about it. Each other. For example, what's the opposite of adding? Subtracting. What's the opposite of division? Multiplying. Those are considered inverse operations because they undo each other, all right? So let's just dive into some math here. A calculator might be helpful. It depends how strong your mental math game is. I love to know I do things right, so I check. I'm kind of one of those people like 2 plus 2. I know it's 4, but sometimes when I'm taking a test, I check it on my calculator just because sometimes my brain can fail me. We are all human, right? Alrighty, so it says practice, solve each equation, justify each step. So the justifying part might be kind of new, but all they want is what did we do to get that? That's what justify means. So let's start here. My first problem is n plus 3 equals -7. So remember, our goal is always to get the variable by itself. So I need to move that 3 over. So right now it's like you're adding 3. Well, what's the opposite of adding 3? We're going to subtract 3 from both sides. And remember, an equation needs to be balanced. So whatever I do to the left side, I have to do to the right side. Otherwise, it'll be imbalanced. And we want to keep it balanced. So let's see here, folks. My n's going to drop down. My 3's cancel because 3 minus 3 is 0. And then it's -7 minus 3 more. See, now this is where a calculator is nice, or you just really got to make sure you're paying attention. -3 minus 3 more. So I'm going more negative, and I get -10. So that is our answer. And how did we get that? Well, look, we subtracted 3, so we would say the subtraction property. Okay, so this is kind of what it's going to look like for these next few examples, okay? So let's try number 2. So g minus a third equals negative 2/3. Again, our goal is to get g all by itself. So how do I undo minus a third? We are going to add a third. But again, do it to both sides. So I'm going to drop down my g, negative a third plus a third, it goes away. If that doesn't happen, we did something wrong. Now what's negative 2/3 plus a third? You should get negative 1/3. I know fractions are kind of goofy to work with, but it's good to kind of be able to go back and forth between whole numbers, fractions, and decimals. So this is just kind of good mental work. And then if I want to justify what operation did we use to get g by itself, look, we added, so that is the addition property. Perfect. All right, let's jump down to number 3. Again, our goal is to get p alone, so I have to get rid of this plus 3.9. So again, to get rid of a plus 3.9, we are going to subtract 3.9 to both sides. So now over here, we have to figure out negative 6.5 minus 3.9. That will bring us to negative 10.4. Drop down my p, those cancel, so we find that p equals negative 10.4. If we justify, what did we do to get p by itself? Well, we subtracted, so that is the subtraction property. Are we feeling okay? Is this kind of, I don't know, have you done this before? I'm quite certain you have, but if it's new, make sure you let me know in class if we went too fast. Okay, number 4. This one says, I think it's a y. Y over 3 equals negative 6. Now, a lot of times we kind of freak out because, I don't know, how do you work with fractions, right? But don't fret. This fraction bar, spoiler, it really means to divide. So you're thinking, what's the opposite of dividing by 3? Well, we know that's multiply. So we're going to multiply both sides by 3 here. So now if I multiply this left side by 3, these 3's actually cancel. So we're just left with y. And now we take negative 6 times 3, and we get negative 18. And what property did we use? We used the multiplication property. Okay. Now these bottom 2 are kind of goofy, or especially number 5. We have 9 pi equals pi x. What? Like, why am I looking at a number, pi, and a variable all at one time? Like, that seems kind of nuts. Well, just remember, pi is just a number. It's hidden by this symbol, but it's just a number, right? So if you can multiply by pi, do you think we can divide by pi? Because really, if I want to get x alone here, I'm just taking x times pi. So if I want to get rid of that pi, let's do the opposite of multiply and divide. So I divide both sides by pi. What's kind of nice is, look, my pi's will cancel here, so I'm just left with 9. And my pi's cancel here, so I'm just left with x. And that's it. My answer is 9. 9 equals x. And what did we do there to get x by itself? Well, we divided, so that is the division property. Okay, one last one. You guys, I don't know, try it on your own maybe, and then check back with me. So pause, do this simple equation, and we will check back. I'm hoping that you paused it, so you already have work done, but check it with mine right now. So for the last time, our job is to get W by itself. So we will divide by 0.05, divide by 0.05. I'm a calculator gal. You guys could do whatever you want. So I'm going to take 1.4 divided by 0.05, and I get 28. So W equals 28. And again, did you remember to justify? What operation did we do to get W alone? Well, we divided, so that is our division property. Woo! Okay, team. Good work. On the back of your sheet, there should be 3 more problems, I hope, that look like this. Okay, let's see how these go. So now we're modeling real life problems. So this is like why these equations are useful, right? I'm not just boring you for the sake of boring you. I would never do that. I value your time. So let's just see what these are. Okay, it says in 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. I totally read that wrong. So I apologize. But our job is to find how fast he ran per second. That's what we're trying to do. So this one, it kind of relies on the fact that we assume you know how to find speed, and you will for sure in your science class this year learn how to do this. I'm not sure, depending on what school you went to, if you cover this, but we use this sometimes. Distance equals rate times time. Okay, this is just a formula. Okay, you will see this a lot in your high school years if you haven't already. So we now can plug in things that we know into this, because our job, it says find his average speed. So remember rate, that's like his speed. That's what we're looking for right now is R. So let's see here. Do I have like a distance amount anywhere? Like how far did Usain run? Well, we were told he ran 200 meters. So that's my D. So I'm going to plug in 200 for D. We're looking for R. We're trying to find his rate, how fast he ran per second. But what was his total time? How long did it take him from the start of the race to the end of the race? Well, they told us it was 19.32 seconds. So times 19.32. And now look, guys, this is the exact same problems that you had before, those other ones we just did. Our job is to get R alone. So how do I undo times by 19.32? Well, we divide by 19.32. Divide. Again, take out your handy dandy calculator. Now I'm going to take 200 divided by 19.32. And I get an answer of 10.35. To say what we're supposed to round to the nearest hundredth. So that is 2 decimal places. So 10.35, and since there's a 1 after the 5, we don't round, so we just leave it at 5, equals R. So if we want to be correct, since we do have units, we can say 10.35 meters per second. That's really fast. He is covering in 1 second, like, I think 10 yards of a football field, but more because a meter's longer. I mean, he's flying. I mean, that is incredible. So, yeah, we did it. So good job. Let's see what number 2 says. It says, suppose Usain Bolt ran 400 meters at the same average speed that he ran 200 meters. How long would it take him to run the 400 meters? Round your answer to the nearest hundredth of a second. So what they're asking us is if Usain ran a 400 meters at this pace, how long would it take him to go 400 meters? So again, we are going to use our little formula here, but now we're plugging in different numbers. If you want to challenge yourself, you could pause this video and see what happens. If not, just follow along with me. Okay, so our new distance is 400 meters. So he's going one whole lap around the track, or a quarter of a mile. His rate we found is 10.35. And we are looking for the total time. So if he is running around the track, we want to figure out how long it takes him to go one full lap. So again, I want to get t alone, that's our variable. How do I undo times by 3.5 or 10.35? We divide by 10.35. Divide 10.35. Again, I'm going to take out my little calculator here, shimmy this over. 400 divided by 10.35. And rerounding to the 100th of a second, so that's 2 decimal places. So we find that 38.6, I have a 4, but a 7's behind it, so I'm going to round up to 5 equals time. So it took him 38.65 seconds to run one lap around the track, or a quarter mile. I mean, obviously he didn't keep up that 200 pace for his 400 pace, because that would be literally incredible. Because I mean, that's just wild, you guys. But that was fun. We did it. Air 5. Woo, woo, woo. Okay, our last real life problems using simple equations. It says on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to -4 at 9:27 a.m. How many degrees did the temperature fall? So we're looking how many degrees was it from 54 degrees to -4? Like, what number gets me from there to there? This problem's almost too simple to come up with an equation sometimes. That happens to us. Like, it's hard to explain it when it's so easy. How I would do this, this is how I would do it. So my end goal is to get to -4 degrees. So I know it's going to equal -4. I started at 54 degrees. Do I know how many degrees I fell? I don't. So I'm going to put minus x, because we don't know what x is. I don't know how many degrees it fell from 54 to -4. And now we have a simple equation we can solve. So I want to get x alone here. So how do I get x alone? Well, I have to subtract that 54 from both sides. So -4 minus 54 is negative minus a -54, yeah, -58. Sorry, brain fart. We're good. And now I have -58 equals -x. So now, do I want a -x, you guys? Like, do you ever talk about that? Like, do we want a -x? We don't. You don't want a negative number. So how do you get rid of that negative? Well, technically, there is an imaginary 1 right there. It's not written, but it's there. So I can divide both sides by a -1, divide by -1. And really what happens, if you type in your calculator here, -58 divided by -1, I get 58. And then if I take -1 divided by -1, I get a +1. So really this is just positive x. So it just changes your signs. So the temperature fell 58 degrees in 27 minutes. That's ridiculous. So if we want to be fancy, we can write the temperature dropped. The temperature dropped 58 degrees. Okay, we made it. Good work. So again, any questions, feel free to email me. We'll talk about them next time I see you in class. So hopefully tomorrow, if that's when you're watching this. Enjoy the rest of your day, and we'll see you then. See ya. Da, da, da.